After the interstellar object, known as 3I-ATLAS, entered our solar system, astronomers began carefully tracking its behavior. This object, traveling at an extraordinary 61 kilometers per second relative to the Sun, immediately stood out. That speed makes it the fastest natural object ever detected within our solar system, surpassing the speeds of ordinary comets and asteroids. From the very start, scientists suspected it was not originally from our planetary neighborhood, but a visitor from another star system. At first, Atlas appeared to be a comet. This idea came from its growing tail and coma, the hazy atmosphere of gas and dust that surrounds a comet's nucleus when it nears the Sun. As sunlight heats up icy material, the surface sheds particles that form bright, extended features. These characteristics matched what we expect to see from comets rushing past the Sun. However, more detailed observations have revealed features that are not so easy to explain, and some of them have left researchers genuinely puzzled. One of the earliest surprises came from its changing color. When 3I-ATLAS was first spotted, it appeared to glow with a reddish hue. This reddish light seemed to come directly from the object's surface rather than from a cloud of dust surrounding it. But as astronomers continued to observe it, the color began to shift. Its glow moved from red toward green. Comets do sometimes display different colors depending on the gases being released, but this particular change was unusual. In August 2025, observations from the Very Large Telescope showed a sharp increase in cyanide production around the object. Cyanide gases can emit a green-blue glow under sunlight, which may explain the shift in appearance. This, however, is not the only unexpected chemical signature. Spectral analysis revealed the presence of nickel without the typical accompanying iron. In natural comets and asteroids, nickel is almost always found mixed with iron, because these metals occur together in cosmic environments. Finding nickel in isolation raised new questions. On Earth, this type of separation usually results from industrial processes, which sparked debate about whether Atlas could be entirely natural, or if some part of it might be artificial. Most scientists remain cautious, but the finding has not gone unnoticed. Another surprise was the development of an anti-tail. Normally, a comet's tail is shaped by solar wind and radiation pressure, which push gas and dust away from the Sun. In this case, however, a tail-like feature extended in the opposite direction, seemingly pointing toward the Sun instead of away from it. This was not an illusion. Astronomers concluded that the anti-tail might have formed as larger fragments of ice broke off from the comet's sun-facing side. These heavier ice particles would not be swept away easily by solar wind. Instead, they would drift more slowly, spreading inward toward the Sun. Sunlight reflecting off these fragments created the appearance of a reversed tail. While this explanation makes sense in physical terms, it remains a rare and remarkable sight, never before documented so clearly in comets within our solar system. Beyond its chemistry and structure, the size of 3I-ATLAS adds another layer of mystery. Early observations suggested it might be between 3 and 10 kilometers in diameter, which is already quite large for a comet. More recent estimates, however, indicate the nucleus could be as wide as 46 kilometers. If true, that would make it vastly larger than any other interstellar object observed so far, possibly 1 million times more massive than the two earlier interstellar visitors, Oumuamua and Borisov. Such a size challenges our understanding of how interstellar objects form and survive in deep space. There simply should not be enough material drifting between the stars to create something of this scale. This has led some researchers to question whether Atlas really is a comet in the traditional sense. Its journey through our solar system is equally curious. On October 3, 2025, Atlas is predicted to pass close to Mars, giving astronomers a valuable opportunity to study it at relatively short range. This timing matters, because already the object's behavior is shifting as it moves closer to the Sun. Its brightness, shape and composition seem to vary in ways that do not fully match expectations. For some, this unpredictability raises the possibility that it could act in unusual, or even unnatural ways when influenced by planetary gravity. One striking fact about its path is how closely it aligns with the ecliptic plane, the flat region in which most planets orbit the Sun. Most interstellar objects detected so far have entered our system on steep, random angles, reflecting their origins in other regions of the galaxy. ATLAS, however, is tilted by less than 5 degrees from the ecliptic. Statistically, the chance of this happening by coincidence is about 1 in 500. The effect of this alignment is that the object will pass near several planets, including Venus, Mars, and Jupiter. The resemblance to planned spacecraft flybys has been noted by more than one scientist, though such comparisons remain speculative. The coincidence deepens when we look at the timing of its closest approach to the Sun. At that moment, Earth will be positioned on the far side of the Sun, maximizing its distance from the object. To some observers, this alignment feels deliberate, as if ATLAS has been guided to interact with other planets, but avoid Earth entirely. Of course, most astronomers explain this as a quirk of celestial mechanics, yet the unusual trajectory has fueled speculation about possible artificial origins. Even its point of arrival adds intrigue. Tracing its path backwards suggests it came from the direction of the Sagittarius constellation. This region of the sky is notable because it has been the source of mysterious radio signals in the past, including the famous WOW signal detected in 1977. While there is no proven connection, the coincidence of location has attracted attention. Whether natural or artificial, ATLAS presents a rare scientific opportunity. If it truly is a comet, it may be among the oldest objects humanity has ever studied. Its journey through interstellar space could have lasted billions of years, even before our sun and planets formed. During that time, it may have passed through supernova remnants, dense molecular clouds, and other extreme environments, collecting unusual elements and compounds along the way. This long exposure to diverse cosmic regions could help explain why its chemistry appears so unusual compared to familiar solar system comets. In the coming months, several spacecraft are expected to attempt observations. NASA's Mars Reconnaissance Orbiter, equipped with the HiRISE camera, may capture images of ATLAS as it passes near Mars. Although the resolution will not be sharp enough to show small surface details, it could provide valuable clues about the object's size, brightness, and whether it produces its own light. Other missions, such as NASA's Psyche and the European Space Agency's JUICE probe, may also have chances to study it in late 2025. These observations could mark the first time an interstellar object is imaged from another planet, which would be a historic milestone in astronomy. At present, scientists are divided. Most lean toward the view that ATLAS is a natural comet with unusual properties, shaped by billions of years of interstellar space. Others remain open to more unconventional possibilities, though evidence is still too limited to draw firm conclusions. What is clear is that this object challenges our assumptions. Its speed, size, chemistry, and path all differ from what we have come to expect from interstellar visitors. The scientific method requires patience. In the coming months, as ATLAS approaches the Sun and interacts with planetary gravity, we will learn more about its behavior. It may continue along a predictable course, confirming its identity as a comet, or it may surprise us with changes we did not anticipate. For now, it remains one of the most intriguing objects ever to pass through our solar system. Astronomers will keep watching, and the world will be watching with them. Whether ATLAS turns out to be a giant ancient comet, a fragment from a distant star system, or something we have never seen before, it is already rewriting what we know about the diversity of objects that drift through the galaxy. Its visit is temporary. Soon it will continue on its way, leaving the solar system behind, perhaps not to return for millions of years. But while it is here, it offers us a rare chance to study something truly alien, a messenger from beyond our sun, carrying secrets from another corner of the galaxy.